Good afternoon, students. Today's topic of discussion is water filtration process. Along with this one, you will be getting one PDF. So let's have a recap of the lectures that we have done till now. Obviously, in the class, we have done the schematic diagram of the water treatment process through the flow chart, and after that, through the digital classes or these classes that we are doing right now, we have done the sedimentation as well as the sedimentation with coagulation and circulation. Now today we will be talking about the water filtration process. Now what is the water filtration process? Obviously it is the removal of some impurities, as we can understand from the word filter, and it actually happens through a media where some particles will be collected and will be removed from the water. Now there are different types of filtration process. Obviously, one is gravity filters, that is actually works through the gravity forces, and another type of filter is pressure filters. For today's class, we will be talking about only the gravity filters. Among the gravity filters, there are two types of filters, that is the slow sand filters and rapid sand filters. So obviously, as the name suggests, the gravity filter, we will be using the force of gravity in different types of sand medium, where the water will be flowing through the forces of under the gravity, and the impurities will be collected in the sand. So first of all is the slow sand filter. Obviously, what is allowed to pass slowly. So that is why the name is slow sand filters. Obviously, they have a bed slope of 1 in 100 to 1 in 200, and depth of tank is 2.5 to 3.5 meters. So here in this particular picture, we can see that this is the slow sand filtration. Water will be coming through the inlet, then they will be going through the different mediums of sand as well as gravity. What will be the size of the sand and gravel, we will be talking later on. And through this particular pipe, the outlet, the water will be collected. Another outlet is there, which is introduced to clean the filter. That is known as also the lateral drains. Now lateral drains placed at a distance of about 2.5 to 3.5 meters, which is actually the depth of the filter. Okay, so these two are 2.5 to 3.5 meters apart. Inlet and outlet, which are also known as the lateral drains. In the lateral direction they are placed. Now, the distance of the walls of the tank is 500 mm to 800 mm. So this two is actually 500 to 800 mm. Now, in this particular figure, there is a cross-sectional direction. You can see that fine sands are there, smooth sands are there, fine gravels as well as smooth gravels are there. Obviously, they will be collecting the different types of sediments which are present in the water. Obviously, we have done the sedimentation at first, then also we have done the flocculation process, through which the sediments will be collected with the help of the different types of alarm, so that their particle size will be increased, and those particles which cannot be separated with the sedimentation, they will be collected through this particular sand medium. Now the best medium, actually the depth varies in 300 mm to 700 mm, and their size is around 150 mm. Okay, now there are two layers, obviously topmost layer, intermediate and lowest. So total depth will be 600 mm. Obviously you can easily understand the depth of the layer and the size of the gravel are given in the three or two layers total. Actually there are three layers in this particular thing. There is a first layer, the sand layer, and then the gravel layer. These two layers are actually combining with different types of sand. One is fine sand and this one is smooth sand. And gravel is constituting of one single size. So gravel layer having a depth of 150 mm, that is the depth obviously, and The size is 40 mm to 65 mm. Now in the filter media, obviously we have seen that it is a sand, and the working principle is that water is allowed to enter the filter through the inlet chamber. Obviously, it descends through the filter media during this process and gets purified. That means the sediments will be collected in the pores of the sand. Some pore spaces are there in the sand in different types of sizes. So there will be the sediment which will be collected. These sand filters are usually work for a maximum filtration head of 750 mm. That is the depth. Now the cleaning purpose, obviously top layer of the sand is removed to a depth of 15 to 25 mm, and the fresh layer of 150 mm depth of graded sand is added. The rate of filtration obviously is 100 to 200 liters per hour per meter square of the filter area, and the efficiency is very high. The bacterial load, it can remove up to 99.9% of the bacteria, and the turbidity can be removed up to 50 ppm, parts per million. Next up is another type of gravity filter, that is the sand filter. Obviously water will be coming with the help of the gravitational force, and you can see that anthracite, it is another type of rock along with the sand is used over here. Now in case of the gravity filters of rapid sand, it is actually very rapid in terms of the filtration process. Also, it was introduced later, that is after 1890s or earlier in the 20th century. Obviously, the filter medium is again the sand, having different types of sizes, and the depth of the sand bed is 1 to 1.5 feet. Obviously, the cleaning process should be there so that it can be worked effectively. Again, the advantage of the rapid sand filter is that it can deal with raw water directly, and no preliminary storage is needed. So these are the two main advantages. And after that, filter beds occupy less amount of space. So in case of the slow sand filter, the space required is very high, and the process is also very slow. So that means filtration is rapid in case of the rapid sand filter, almost 40 to 50 times that of the slow sand filter. So here is a comparison of the rapid and slow sand filters. Obviously, we have seen that the area required for rapid sand filter is very less compared to the slow sand filter, as well as the rate of filtration is very high. When it is slow sand filter is 100 to 200, it can actually move up to 400 if we require, if we design that in that way. And in case of the rapid sand filter, it is 4,000 to 7,000 liter per meter square per hour. Size is also, in terms of the diameter, the sand size is, it is very larger compared to the slow sand filter. Now the cleaning process is always difficult for the slow sand filter, that is the scrapping, but there is an advantage of the slow sand filter in case of its operation, that is the less skilled less skilled persons can also use this particular type of filter. Obviously, the color removal is better in case of the slow sand filter, and the removal of bacteria is almost equal, but in terms of the percentage, the slow sand filters are slightly ahead. So that's it. Obviously, it is the today's class. Obviously, we have sent you a video, sorry, a PDF along with this one. I hope you will be going through that one. So in our next class, we will be talking about the different types of filters in terms of the pressure filter. Obviously, pressure filter is there in your syllabus, and other types of filters are also there. So we will be talking about them. Thank you.